Alright, so in this video we are going to go through how to take some derivatives of exponentials in the form e to the x and trig functions, specifically sine, cosine, and tangent. So to get started, I am just going to write down the derivative rules we're going to use here. Instead of talking about the proofs of where these rules came from or describing why they are what they are, I'm leaving that to separate videos where we talk about those independently. So here I'm just going to write down the rules as sort of a summary. So the first derivative rule we have is that the derivative of e to the x is itself, it's e to the x. Then we have that the derivative of sine is cosine. We have the derivative of cosine is negative sine. And then lastly, we have that the derivative of tangent is secant squared. We also have derivative rules for the other trigonometric functions. We're not actually going to use them in this video, but I'm just going to write them here so that you have them. We have that the derivative of cosecant is negative cosecant cotangent, the derivative of secant is secant tangent, and the derivative of cotangent is negative cosecant squared. And similarly, if you're wondering where those derivative rules came from, I have a video where I go through those proofs as well. Okay, so the rest of this video is just examples where we're going to practice using these derivatives. So I'm going to put them on the screen so we have them all here with us as we work through these examples. And let's get started. So at any point you can pause and try these on your own. I'm going to do two with you to begin with, and then I'll give you some prompts to pause, but you do you pause if you want to at the beginning here. So our first example says if g of x is negative 2 e to the x, find g prime of x. So we have a function, we're going to find its derivative. To help us unpack the pieces, I'm going to rewrite this using some derivative notation. So I'm going to write that g prime of x is the derivative with respect to x of negative 2 e to the x. So just rewriting it, but then I can factor that negative 2 out using the constant multiple rule. And then we're just left with negative 2 times the derivative of e to the x. The derivative of e to the x is itself, so we end up with negative 2 e to the x. Turns out this function is its own derivative. Alright, so that was an example with e to the x. Now let's do one with a trig function. I'm going to say if h of x is 6 sine of x, find the derivative with respect to x of h. So if I was doing this derivative on my own, I'd probably just jump straight to the answer, but here I'm going to write out lots of steps just to show you sort of how I'm unpacking it in my mind. So we're taking the derivative of h of x. This is 6 times sine of x. And to take the derivative, I'm going to factor that 6 outside. So I have 6 times the derivative with respect to x of sine of x. Then I know that the derivative of sine is cosine, and so I'm just left with 6 times cosine as my derivative. Hopefully now that you see this, you could understand how you could jump to the answer right away. So 6 times sine, derivative of sine is cosine, so the whole derivative is 6 cosine. So again, writing out all the steps isn't necessary, but I think it can be helpful just to really make sure you know why you're doing what you're doing. Okay, let's do an example now where we put these types of derivatives together. So if f of x is 7 e to the x minus 2 cosine x, find the derivative of f with respect to x, the df dx that I've written there. So this is a good time for you to pause, try this on your own, remember what you know about taking derivatives, and come back when you've tried this out. Alright, so let's come back together and do this problem. So we're taking the derivative of f with respect to x. That's the derivative of 7e to the x minus 2 cosine x. So I'm going to split this up into two pieces. So I have 7 times the derivative of e to the x minus 2 times the derivative of cosine x. Then the derivative of e to the x is e to the x, and the derivative of cosine x is negative sine x. And then I have 7 e to the x plus 2 sine x after I have simplified. Basically, that negative on the 2 and the negative on the sine come together to be a positive, so altogether I have 7 e to the x plus 2 sine x as my derivative. Alright, so let's do one more example. I'm going to say find the derivative of 1/5 tangent x minus 8 over x squared plus e to the x. So I think you can give this one a shot, pause the video, try it out, and come back and we'll finish it together. So I'm going to separate out the constants and split this into 3 pieces, just splitting it up like I've been doing so far. Again, you don't need to write all this all the time, I'm just really trying to show all my steps. So I have 1/5 times the derivative of tangent minus 8 times the derivative of 1 over x squared plus the derivative of e to the x. So derivative of tangent is secant squared. Then in order to take the derivative of 1 over x squared, I'm going to first rewrite it as x to the negative 2. So this is review from some previous derivatives we've done using power rule. Then the derivative of e to the x is itself e to the x. So writing that all out, my next step is just to take that last derivative. The derivative of x to the negative 2 power is negative 2x to the negative 3, again using power rule, and now we just simplify. So I have 1/5 secant squared x plus, it becomes a plus with the minus minus, 16x to the negative 3rd power plus e to the x. Now, it's totally alright just to leave it like this. I'm going to call this my final answer, but truthfully, I'd probably rewrite it one more step just to get rid of that negative exponent. Don't feel like you have to, but I'm going to do that really quick. So x to the negative 3 in the middle there, that's actually 1 over x cubed. So altogether, I have 1/5 secant squared x plus 16 over x cubed plus e to the x. Alright, so this means we have successfully taken the derivative and we've completed this example. So that's it for examples about using derivatives with exponentials and trig functions. We're going to use these more when we start doing product and quotient rule, but for now, this is all we have. Thanks so much for watching, and I will talk to you in the next one.